Okay, so for my honors project, I chose to make a toy. Dang. Came loose. There we go. One of the disadvantages of Legos, I suppose. Anyways, it is a Lego car. It is made of 9 Lego blocks, as well as two sets of wheels and axles that you attach onto this big massive box. Okay, and I created a little racetrack here. There's the finish line. There's our start line. Okay, I measured it out, and it is about 2 feet. Let's see. It's right about right there. See from this point here. Then you scoot it. Let's see. There. There we go. Right around in there. So, I had to find the distance from here to here in order to make my calculations here in a minute with the momentum and the kinetic energy and acceleration and velocity. Okay. So, I also need to weigh my car to find, so I'll be able to find the mass value. So, don't know if you can see it, but it's right around in this area right in here, right around 50. I don't know if you can see it real well. It's right around, it's really more around 30, but I can change that in a minute. Let's see. Put this to 30 grams instead of 50. $30. Okay. Now, I'm going to find my car. There it is. Right there. I'm going to put it on our starting line, and I will time how long it takes. This might be a little bit hard because I've got to set the timer, push the car, and video this all at the same time. Okay. Of course, before I recorded this, I measured that it was 2 seconds, but I figured I would show it because it might be better that way. Let's see. I'm going to try to start this at the same time. Just a moment, see if I can set this up right here. Well, I don't know how well this is going to work, but I'm going to try. Alrighty, so we're going to go start, roll it. There we go. It took about, stop it. Well, it says 4 seconds, but I really think that it's more around 3 or 2 because I tried it out several times earlier with help, and it was about 2 seconds. So it's probably 2 seconds, really. I wasn't that fast. Okay, so either way, it takes 2 seconds for this 2-foot racetrack. And now it's time to do our calculations. Now, first let us find the acceleration. The acceleration is the distance divided by the time squared. So we need to put our distance into meters. Well, that's a problem because I did this in feet. So what we need to do is we need to have this in centimeters because you can actually convert centimeters to meters. And so what it would be is that, see, in this ruler, there are 30 centimeters in 1 foot. So I had 2 feet. So it'd be 30 times 2, which would be 60 centimeters. So 60 centimeters is equal to 2 feet. And so the thing is, there are 100 centimeters in a meter. So what it would be, instead of 60 centimeters, we're going to make this into 0.6 meters. So then we're going to do like 0.6 meters divided by our time squared. And we established that our time was 2 seconds. Okay, 2 seconds. And we are going to take our 0.6. Let me get my calculator over here. Okay, so we're going to turn this puppy on. There we go. We're going to take our 0.6. What crap? Dang. Okay, we're going to take and go 0.6. See? Okay, times. Actually, we're going to divide that, sorry. Divide by 2 seconds to the. Where's the squared thing? There we go. Squared. See, 0.6 divided by and divided by 2 squared. And that's going to equal 0.15. So let's see what we got. So our acceleration would be 0.15. Our acceleration is, acceleration value would be equals 0.15. I'm looking at the video while I'm doing this, so it's kind of really sloppy. But anyway, that is our acceleration. It would be m per s squared. I heard back in physical science there was no naked numbers. You don't leave them without a ending. Alrighty. So we have our acceleration value, which is 0.15 ms squared. Now, moving on to velocity, which is the distance divided by the time. Well, that's simpler than what we just did up here with the acceleration. So we have our 0.6 still, right? We have our 0.6 from when we solved it earlier. We just put it down here in our formula. We just substitute. Plug and chug. We put our t, which is our time, and that would be, we would have 0.6 divided by 2 seconds, which would be, let's see, let's go over here. There, let's see, our 0.6 divided by our 2 seconds, which is going to equal what? 0.3. Alright, so our velocity will be, what am I doing here? This is supposed to be equal to v. Okay, so our v is going to equal what we got over here, which was 0.3. So 0.3 equals, let's see, hang on a minute. The 0.3 equals our v, which is the velocity. Actually, it would be 0.3 m per s. 0.3 m per s is our velocity value. So, now, momentum P equals mv. Alrighty, so now it is time to use that mass value that actually the weight value to get the mass. So the weight value that we found over here on the handy dandy little scale.